We're going to move into a discussion about the new energy system. What Bob has shown us today is technologies that could form a key part of that in the years to come. About harnessing the sun directly in these machines. We've always harnessed the sun's energy. That's what happens when you burn coal. Hundreds of millions of years ago, little critters and plants photosynthesized the sun's energy, and they were intermediated by high pressure in tens of millions of years, and they produced that coal that we burn. We're already harnessing the sun's energy in a much smarter way, of course, through solar energy. And that, to me, is one of the most exciting things that is happening today in the energy system. How does solar energy help us meet both our energy goals, but also our sustainability goals? So in order to help us understand that, I'm really happy to have Vera Pinto Pereira from EDP, which is formerly a Portuguese but now international energy company, to help us understand what's happening in the world of solar. Vera, thank you.
Hi, everyone. Let me just put my stuff down here. It's a pleasure to be here, very exciting. Super exciting to listen to the previous presentation, honestly, and all the sessions this morning. Today I'm actually here to talk to you, yes, about energy, in particular the sun, but also about what can seem like really small changes, small steps outside our comfort zone can actually make a world of difference and contribute decisively to what we must call the energy decade. So just a note on small changes. Did you know that what makes us unique actually only represents 0.1% of our DNA? So it's 0.1% is at the core of evolution, innovation, impactful action. It really doesn't take a lot, a big step, a lot of difference to really make an impact. In fact, over the course of history, it was small steps that changed the world. And here are a few, but it was small steps, and all of them, just to put in context, obviously also required adaptation, breaking everyday habits, a new learning curve, investment. So it's not, they now seem obvious, but it wasn't always easy to adopt the wheel or to actually put electric wiring in your house to use a light bulb. And these are just a few. I mean, you have the plow, the spinning jenny, eyeglasses, there's just canned food. These are such simple, small steps throughout the course of history that changed the way we live today. Now, with these small changes, energy in the post-industrial and modern era became the lifeblood of economies. With it came amazing progress. I mean, we're here today, and everything we're living through, and AI, it's all powered by energy. It's extraordinary. However, unfortunately, it's also, this overuse of fossil fuels have also brought the world to the brink of collapse. And today, the only way we're going to continue to have thriving economies, benefit from all the extraordinary aspects of AI that were discussed here throughout this morning, is really if we reinvent the energy system, the way we generate, store, and consume energy. So it really is time, not for the energy transition, but it's time for an energy revolution. We need a world that is powered by clean energy. In 2024, the world has finally risen that dramatic 1.5 degrees centigrade. It's now warming at an unprecedented rate, and the consequences are everywhere. Be it the fires that we've just been seeing in California, and there is climate impact there. Be it the severe floods that devastated Santa Catarina in Brazil about a month ago. Be it the horrible floods that devastated the region of Valencia in Spain. And these are all urban areas that it could be here, right? It's not somewhere out in the Amazonian forest. This is at our doorstep. And there is only one solution to this climate change, and it's called decarbonization. Now, the energy sector is obviously the largest contributor to global greenhouse gas emissions, which means that by decarbonizing our energy system, we decarbonize a large part of the economy. And the world has agreed I know we're good at setting these goals. We have agreed to carbon neutrality by 2050. But it's a massive commitment, and we're at a decisive point for the planet, and there is absolutely no other way. And unfortunately, the world continues to swing between great moments of consensus, and we were all pretty happy with what came out of the COP28 when 200 countries pledged to tripling renewable capacity generation by 2030 and phasing out fossil fuels. But then, cut to a couple of days or weeks or months after, and you've got multiple moments and voices of doubt and denial. Now, I believe human nature obviously is, unfortunately, first and foremost, driven by self-interest. But I also believe that human nature is at least partially driven by concern for the collective. But even if that were not the case, we are at a point in time where this collective interest is actually in our self-interest, because the next wildfire may actually be right at our doorstep. So we should keep this in mind and really take action. Now, alongside climate change, this energy transition, or revolution, as you may want to call it, will actually also bring, strengthen energy security and reshape geopolitical dynamics. That's also sometimes why we get some pushback. So transitioning to renewable energy is, it's about decarbonization, it's about sustainability, but it's also about creating a more secure and resilient energy future for many countries, gaining a certain independence from third-party energy suppliers. Finally, renewable energy also drives affordability. It's the cheapest source of energy, whichever way we want to cut it, and all things included. And while we are reshaping the sector, new clean energy sources are actually generating millions of jobs and boosting economic growth. So this revolution is a tremendous challenge, and we don't have much time, as I said. And as we transition, we're actually falling short in pace and in scale. And we all need to be on the same side of history. Whether we acknowledge that renewables have economic, social, and environmental benefits or not, there's no other way of cutting it. We all have to bet more on wind, on sun, on hydro, and on fusion. Context hasn't been always on our side. There have been good moments, there have been not so good moments. At the time being, we've got, again, high cost of capital, an increasing NIMBY effect, that famous not in my backyard, looks great, not here please. Lack of political support, which may actually get worse in the context that we're living. And all of this is jeopardizing the pace of investment. So we really have to keep our eyes on the ball, because we only have less than 2 decades to change an energy system that actually took 2 centuries to build. And global electricity is about to explode, continue to grow. Whatever curve and forecast we decide to assume, it is, we will see a substantial increase, if nothing else, certainly driven by all the big tech and the AI, which are really going to push this demand forward. And I really believe it is in the combination of the sun, the wind, and the water, aided by exiting technologies that will have to transition out, but also entering technologies like fusion, that we have the ability, and we will have the ability to power this demand. Now, today I'll just spend the next few minutes talking about the sun, that classic fusion that is accessible to all. Solar energy is a source of, obviously, sustainability. It's 96% less carbon intensive than any other technology, all things included, and including all the materials considered, and it's virtually inexhaustible. It brings also relevant savings, and it protects families and businesses from market price volatility, and we're all very familiar with that, especially here in Europe over the last 3 or 4 years, as well as enabling savings. So it can power homes, it can power buildings, vehicles, even spacecrafts. NASA's Mars rovers, for example, are powered by the energy of the sun. So it's not surprising when we have market projections that put so much expectation on solar energy capacity growth. Solar alone is forecasted to amount to 80% of all global renewable capacity growth between now and 2030. And now, highlighting into the piece of solar, which is what I'd like to talk about today, distributed solar generation will account for at least 50% of all of this capacity coming into the market. And this is where I go back to my small step in this equation, because all of us here individually are actually in a position to take this small step and to determine how we want to participate in this energy transition. So solar DG, as we call it, I will abbreviate solar DG, is economically beneficial, it's much faster to deploy, it's accessible to all. And by producing energy locally, we actually become, we empower families to participate in this, in green energy, but we also give them a lot of protection from the energy from the grid and from these volatility spikes. In the last year, solar DG alone grew almost 30% as families, services, industries, public buildings all installed solar panels to harness the power of the sun. At EDP, this is a very important piece of our business. It's as Roman mentioned this morning, it's actually one more of our cathedral thinking pieces in our business model. Today we have about 15,000 solar installations in companies, and we have almost 200,000 installations in people's homes. This is 3 gigawatts of solar DG contracted energy. Now, just for the, as a reference, it's almost 3,000 football fields covered with solar panels. But with one difference, they're not out there on the landscape. For those of you who have aesthetic considerations, they are on top of buildings, rooftops, carports. So a different, takes away part of that NIMBY effect around renewable generation. And the business case has been volatile. And particularly here in Germany, it has been challenging. We had enormous excitement around solar DG when the war between Russia and Ukraine took off, as prices spiked in the European market. Everybody rushing to put solar panels on their rooftops. But now as prices cool down, here in Germany and in other countries like Spain, for example, we have seen the market collapse, especially when it comes to residential. So it's important that we're in this for the long run, that we continue committed to this technology as an enabler of the energy transition. And much like the light bulb in the 19th century, requiring people to overcome their initial skepticism and their initial resistance to actually invest in wiring, electric wiring in their homes, for something that completely changed their lives and lives of generations to come, I challenge all of you to take your small step forward in your own energy transition and to actually be, as Roman said, a good ancestor to generations to come. Thank you.
Vera, if you stay on stage, why don't you take this seat? We'll bring up the rest of the panel. We've already met Bob, and we've got Vijay Vaitheeswaran, who's the Global Energy and Climate Change head honcho at The Economist.
Something like that.
Do you change the climate or produce the energy, Vijay?
I'm the climate innovation editor, so I look at how we tackle the challenges of climate change.
Well, you've heard 2 different perspectives. I think they're actually quite similar. They revolve around fusion in just in slightly different ways. One of the things Bob said earlier was global energy demand is going to just go through the roof. Sometimes when we think about this, we think, can we really afford that? Can we afford that environmentally? Do we really need it? What's your take?
So what's going to happen with global energy demand? If I remember correctly, your slide said clean electricity demand, to be quite precise. But the bigger question you're asking, I think, is a huge one. The answer depends on if the future belongs to triple F or triple E, and I'll tell you what I mean. If you just look at the drivers of what we can see in the energy world ahead, you'll see massive demand for the things that energy can power. We all know about AI, data centers, hyperscalers. We've seen the headlines and the concerns about energy consumption. The bigger driver of demand for the good things that energy can bring will be actually air conditioning, and a billion people in Africa and more in India taking their rightful place in their own middle classes as their economies industrialize, grow. Those continents enjoy their demographic dividends. So the question, if you just take the path of FFF, which is fossil fuels forever, then yeah, it's going to be a heck of a lot more energy consumption. The history of what we call energy transitions is actually better called energy additions, right? We still use wood. We use more wood and more biofuels than we did back in the day. We use more coal today than the days of the original steam engine and so on, right? We've added new energies. But that cannot continue in an age of carbon constraints, in a climate-concerned world. So that's what's new this time around. That's why I point to the triple E: electrification, efficiency, and emissions-free energy. If we can push these levers aggressively, then what you find is we get to a future where we, rather than consuming ever more energy, we use the energy we make cleanly and efficiently at the point of use. Just a quick note on each of those. We're entering an electricity super cycle, I wrote recently in The Economist, and that's because we're shifting towards how we use energy at the point of use towards electrification, whether it's industrial heat or whether it's through the very popular heat pumps. I gather they're very popular here in Germany, at least with politicians and newspapers.
Well, how many people have a heat pump in their home? We can do a...
Exactly. And how many people have followed the controversies with some amusement and entertainment about heat pumps? Exactly. In England as well. So I never thought I would talk so much about heat pumps as I have in the last 24 months. But electricity is just a much, much more efficient way of using energy. We know this. Transportation, cars moved on electricity, deliver 80, 90% of the efficiency at the point of use. If you burn fossil fuels, it is a terrible, dirty way to do things, but also partial combustion leads to the heat escaping. It's a terrible way to use energy, much less efficient. So if we can electrify more and more of the world economy, we're going to find a dramatically efficient way, but also less need for primary energy to be used. So that's electrification. The second point, of course, is efficiency. We can dramatically improve our efficiency in the use of energy. And one of the tools, AI itself, could be one of the greatest resources we have in sparing energy, materials use. We can imagine the application, and already I've seen in steel mini mills and cement factories, early applications of AI, without even getting into more advanced applications. We can see quite a dramatic increase in the rate of improvement of efficiency in how the world uses energy. And so if we push that lever, we get to point 2. And of course, point 3, emissions-free energy. We've seen a couple of great examples mentioned. More immediately, it'll be solar. The solar revolution continues. And Azeem, you've advocated both in your writings and today the emergence of these emissions-free technologies really as technologies following the kind of exponential curve that we've seen with the digital technologies. That explains why we might end up 20, 25 years from now providing a lot more energy services without using a lot more energy, indeed maybe even less energy. But that's hopeful, and that depends on these levers, and we should work hard to, and that's what I advocate for us to do. It's not foregone, but we need people to make it work.
Thank you. And I think what you brought out there as well is this interesting idea that of all of the burning that we do, the vast majority of it is wasted. Yeah. And as we move to the solar technologies and the fusions technology, that efficiency rate will go from 25% to 99.9% potentially. So that is a new way of thinking, and I'm also conscious of time, so we're going to go now for quick responses. It's a new way of thinking, so what is the thing that is most misunderstood, do you think, by the general public about the future energy system? What do people most get wrong when they think about it? Maybe, Bob, you'd like to hop in.
People have a very hard time with scale. So like the energy system is so incredibly large that it's almost mind-boggling. And so that can have 2 effects. One, on one end, you can feel like what things that you do don't matter because the scale is so big, if you understand the scale. And we certainly have there's certainly incumbent energy system people that are like, oh, it's so big, we can't ever change it. The other thing is you can be too optimistic. That oh, if you don't know the scale, then you can think that it's going to be easy. It is not going to be easy. It's going to be very hard. But at the same time, that combination of very large scale and hard means it's a huge economic opportunity. Mm-hmm. That the businesses that solve this problem will be the largest businesses that humans have created. Because it's the largest problem that humans have created. And so that sense of scale is totally lost.
Right. Right. I like to think of it less of a problem that we've created, but the thing that we need to live in a complex
society.
Yeah. So, I mean, Vera, from your perspective, especially as your business deals with consumers, what is the thing that people most misunderstand about the transition and what this future energy system will look like?
Well, from two perspectives. One is what in general I think is misunderstood is the scale and the complexity. There's no point in pushing for renewable generation. We have to change the entire energy system. We have to address the grids. They have to be prepared to deal with the intermittency that come from renewables. They have to be able to deal with curtailment.
These are all technical terms. Maybe we should just spell out.
Renewable, unlike hydro and coal and gas that produce energy at a base load level, so 24/7 all the same. When you're talking about solar, there's a lot of solar during the day and there's no solar at night. And wind, it's only when the wind blows. So
the famous Dunkelflaut that we have here. Did anyone here enjoy the Dunkelflaut electricity prices we had a few weeks ago? Not a single hand goes up. Sorry, I interrupted you. So come back to curtailment.
So when this happened, either the grid is prepared to deal with this, or we're going to end up wasting part of that energy. And so that's what's called curtailment. Now, curtailment is, first and foremost, a waste of energy. And second, it's a big impact on the business case, because we're producing energy that doesn't get used for anything and doesn't get monetized. So it's problems like these that inform us that you can't just push for one thing. You need to deal with it altogether. You need to deal with it from a regulatory perspective. You need to be prepared to pay for what in terms was called capacity, right? To make sure that there is always capacity to address the demand in the grid. And so that needs, the capacity of the future is going to be in batteries. So we need to regulate in that sense. So this is, from an overall perspective, I think it's the complexity, which is not necessarily being addressed in this holistic way, pushing the whole ecosystem forward at the same time. And that requires a lot of very different stakeholders coming together, which, as we know, is complex. From the customer perspective, I think that what gets least understood is prices. It's always been that way, whatever the industry, but in energy, when people think of it, oh good, more renewables means it's going to be cheaper energy. Yes, it is over the longer term, but we're still talking about very significant investments that have to go into putting up these new wind farms and solar parks. We still have to do major investments in the grid. We still have an energy mix that can't just shut off gas altogether, because we need to ensure that we have this base load to address energy demand. So it's not automatic, and people are, from a consumer perspective, people are short term.
I want to bring Vijay in on this one. I often get this challenge, right? To Vera's point about consumer misunderstanding. I show my curve, it's coming down. And they go, if solar is getting so damn cheap, why is my electricity bill so damn high?
Yeah. We have to separate cost of transition from the long-term steady state that you're pointing to. In the long term, and which may not be that far off, we just look at the capital intensity versus the ongoing operating cost. With solar, capex heavy, operating expenses, fuel is free, right? It's not zero, but it's different from a natural gas plant, for example, right? Where you have to constantly be at the whims of global LNG markets and gas pricing. And so fundamentally, we're shifting to a different paradigm over the long term, where you'll find, I think, that after the costs of transition, which are significant, that need to be borne, including investing in new technologies and transition technologies, we're going to get to a world where we'll actually have savings both in the absolute level of pricing, because again, a lot of the fuel can be free depending on which choices you make, or very low cost. But secondly, the volatility can be extremely low as well. And that's why I think there's one misunderstanding there. The other point is that people think, oh, this is going to cost too much money that we don't have. Actually, the world, as to Bob's point, this is an asset-heavy industry. The world spends an enormous amount on electricity, oil and gas, on industrial infrastructure related to all of those things. We spend in the trillions. And so this is really the largest enterprise on earth, counted up properly, which renovates itself on a regular basis. The question is it going to renovate itself to reinforce that triple F, fossil fuels forever mindset, or are we redirecting those resources with appropriate incentives from government and encouragement from the marketplace towards the triple E, towards the efficiency, towards that exponential curve that we talked about? Because that one-off push in incentives in that direction, I think, will set us on a glide path towards what we talked about, that is ultimately getting to both emissions-free energy, but also one where we don't have the same kind of volatilities and dependencies we have in the fossil system.
You're a great innovation guy. You're promising me the return some point in the future. Some point in the future. I want it now. So how do we get it quicker? Use the G word there, government. Is this energy system the transition that we're going through, does it require more government intervention through permitting or market reform? Does it require more finance, or does it just require the brakes to come off and more innovation? Bob, why don't you go first? We'll quickly come to Vera after that.
Well, so coming from it from an American entrepreneurial standpoint, which is, it's pretty silly to think that like digging up rocks and burning them is the absolute cheapest way that we're ever going to make energy. So why don't we go out and build new things? And like when those things are better, they will be adopted because we're already turning it over. So this is not a collective action problem. This is like a lack of animal spirits problem. Stop talking about collective action and go build awesome businesses based on a technical stack that's been built for the last 100 years and has not been applied to the biggest problem in industry. That's sort of my view. So take the brakes off, let's go.
Vera, your perspective on this.
So, completely agree. However, if we think about it, we already have a lot of the technology that is required to address the larger part of CO emissions. The problem is scaling that up and making it a business, right? And so that they can actually do what they have to do, and they're at a commercial point. And that requires, and it's especially here in Europe, it requires clear regulatory frameworks, regulatory stability, the right kind of incentives, very much along the lines of the IRA that we have in the US, but not necessarily like the commitments we have here in Europe, which don't then translate into the right kind of incentives. So it is about figuring out those new technologies that are necessary to push this forward, but a lot of them already exist. So what we need is to innovate in the processes and the operations to make them scalable and create the conditions for the investment to flow into these technologies and the right kind of business cases to exist. We've already invented batteries, but they're still out of the money in most of their use cases.
Right.
Why? Because the ecosystem, the regulatory framework, the way it's financed doesn't play to it.
Right. So what I love here is that we really did have the canonical American and European responses on the DLD stage. Vijay, I'm really curious about your perspective here. I think a lot about the Texan energy system. You know, Texas is not a hotbed of government regulation in general, but it is the most dynamic, clean, renewable energy system market in the US. I mean, it's remarkable. So they seem to be able to do that without kind of big government, to my knowledge. Help us make sense of these wise comments.
I was going to take you. I spent a lot of time in Texas covering energy, as I do. And of course, it's a tale of two energies, right? The Permian Basin, great shale fracking going on, and they're doubling down. It continues to be an important source of oil and gas for the world, really. The U.S. is the biggest oil exporter now and the biggest LNG exporter. But at the same time, the leading wind state in solar state now is not California any longer, it's Texas. Massive battery projects coming online in Texas, not because of any state-level subsidies, right? They have a Wild West marketplace, and you can get returns. And so that's not to say no subsidy ever did any good. Of course, there's infinite industry arguments that you can have on different kinds, and solar in Germany clearly played a role. Thank you, Germany. American R&D played a role. German subsidies in scaling up. The Chinese efficiencies at getting things to market at scale, massive scale. Thank you, Chinese taxpayers, right? As a result of that wonderful flywheel effect, the world now has exponentially decreasing costs on solar at scale, which will benefit all of the world. But a place like Texas, you don't need subsidies to make money, and don't mention the word green. They get very upset. They invest in batteries and they invest in solar because it makes money.
Yeah, absolutely, absolutely. So Texas, bringing the Texan model over to Europe is probably harder than delivering a working fusion reactor, would be my view. But I would encourage people to look at the ERCOT, ERCOT example. We're really close on time, so I want to just ask one last question. It's going to come to you first, Vera. So EDP obviously produces a lot of energy through solar and through other mechanisms. You happen to be sitting next to a man who is building a brand new way of producing energy really, really cheaply, really cleanly, and forever. So you've got a chance now to tell him what specification the product needs to have. So what would you need in order for Bob's product to look like in order to buy it and buy lots of it?
Well, as a client, I need a long-term contract, prices within, at market levels, and clean energy, which by default you are. So it really doesn't get more, and by the way, 24/7 if I want to power a data center.
That's great. So the key thing there was prices below where they currently are today. So Bob, when can you do that for us?
We think we can do that relatively soon. We think that the first generation of plants can do that.
The first generation, so the ARC one that you're building outside of Boston, the Spark, the little one.
The Spark?
Not the Spark one.
The ARC one in West
ARC
Virginia.
one in Virginia, yeah.
Yeah. So that is within 10 years?
I mean, you got to build it and see it, but that's one of the, you wouldn't do it if you thought that it couldn't get in the money. And one of the things about fusion is you add up all this stuff, it's not a lot of stuff. And so it's the right stuff in the right way with innovation in it. That's very different than what we're used to in other energy systems. I love solar. Solar's great, but solar's a pretty weak energy source because we're 8 light minutes from the sun. Just bring that 8 seconds closer, put it in a machine.
Right. I love the thinking. So Vijay,
turn it on all the time and where you want it.
Vijay, it strikes me though, Bob can deliver it, Vera can buy it. It's a hard idea in people's minds, right? In the incumbent energy systems' minds. What do you think they need to really understand for Bob to have an order book that is even bigger than the one he may be building?
I think if he can deliver what he promises, a sun in a box at a lower price than incumbents, he'll dominate this marketplace. He and others that come after him with a competitive product. If he can't do it, then he'll be out of the money and he'll fail. But I think he'd be all right with that as an entrepreneur.
Yeah,
we'll agree.
I think that's as simple as that. If he can do what's on the tin, what is advertised, it will surely succeed. And I think it'd be very hard for, unless legacy systems are paid up and we don't have emissions controls or something, you imagine a retrograde perspective. But it seems very hard. Any new systems could beat fusion if it delivers its promises.
Well,
I'm holding my breath.
You gotta
let's
build
see.
it.
Yeah, let's see.
Either way, I think we can say, here comes the sun. Thank you very much to the panel.
Great.
Wonderful. I have to stay on. Great. Thank you, guys. Thank you so much, Vijay. That's great. I'll still be up here. Right.